So question 6, we're looking at heat flow. Now, John Leslie was a scientist who investigated heat and thermometers, and he used a hollow metal cube with different surfaces on each side, which was filled with boiling water. And then used a radiation sensor to look at how much radiation was emitted by each surface. The students' results are shown below, but you have to link each colour surface to the correct meter reading. Now, what we know then is that dull black is the best emitter of heat, followed by shiny black, because black is the best emitter. Shiny silver is going to be the worst. Now, if you got one right, you get 1 mark. You need to get all 3 right to get 2 marks there. Now, the temperature of each surface is the same, but the radiation sensor gives different reading for each surface. What can you conclude from this? Well, we can conclude that different surfaces emit radiation at different rates. Now, this experiment is all about emitting radiation, and therefore we can write a conclusion about that. Now, lots of you have written conclusions about black being the best absorber or silver being the best reflector. Now, you're correct in terms of, black is the best absorber and silver is the best reflector, but you cannot conclude that from this experiment. So if you've written those things in addition to what I've written here, then I'm going to give that as incorrect, because you cannot conclude those things from this experiment. John Leslie invented a differential thermometer too, which is filled with air and a tube connected between them that contains liquid. The only difference being that the bulbs are painted different colours. Now, we're looking here at the height of this liquid, okay, and so they're asking for an equation that links pressure difference, height, density and G. And what we're looking for is the pressure difference is equal to the change in height times the density times G. Then you can write them in words or symbols if you use the correct symbols. And then you've got to calculate the pressure due to the liquid at X when the height of the column is 0.25 meters. So the change in pressure is change in height, which is 0.25 here, times density 1260 times G. Now G, if you ever forget, is given to you right on the front of the paper, okay, as 10. So we're going to put 10 in there, and that gives us, I think, 3150 pascals, and Pascal is the same as a Newton per square meter. So they're going to give 1 mark for the values you put in, 1 mark for your answer, and 1 mark for the unit. They'll also accept it if you didn't use 10 and you used 9.8. You get a slightly lower answer instead.